on the top of your notes, where it says square root, your notes say the square root of a number is the number that you guys need to fill in, multiplies itself to get the radicand. So you guys need to write what I just underlined in red. So right next to it, right here, where it goes that, dot, 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 dot. After that, those dot, 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 dots, you need to put multiplies by itself to get the radicand. You do not necessarily have to write what I put in the parentheses there. Unless you're like me, I like to write every single last thing out. A lot of people aren't like me, though, and prefer just to write the shorthand version. Now, we have a new term here, radicand. How many of you guys have heard of radicand before? Anybody? Did you guys do square roots and squares with Carlos and Nimmons last year? Yeah? Okay. So the radicand, well, first of all, what's this thing called? Square root sign. The number that's in it is called the radicand. I would put that on there, on your notes, because you're going to need to know that. So I would label that, because you're going to need to know what the radicand is. Next week, we're also going to talk about radicals, but right now we're just going to talk about the radicand. Okay? So I would put on your paper the square root sign with a number in it and an arrow drawing to the radicand to know that when I refer to the radicand, I'm talking about the number that's up under the square root sign. Jalen, can you write that down for me, please? Good, Jaden. Good, Damon. Okay. Now, as I said at the very start of class today, using a multiplication table is going to be so beneficial to you guys. It's going to be extra helpful, especially for this next part. If you look at the next part of your notes, it's saying list the first 12 perfect squares. So if we're listing the first 12 perfect squares, all I'm doing is looking on my on my multiplication table, and I'm looking at my first row and thinking, what's 1 squared? What's 1 squared? So what's 1 times 1? 1. So 1 squared equals 1. So then my next one, if I want the first 12 perfect squares, what's 2 squared? What's 2 squared going to be? Which is? So I'm going to start my list down here. So I have 1 squared, which is 1. 2 squared, which is 4. So what number is after 2? What number is after 2? 3. So what's 3 squared? What's 3 squared going to be? Do you guys understand what I mean by when I say squared? I mean, what's 3 times itself? So 3 times 3 is 9. Okay, so we've done 1, 2, 3. Now we need to do 4 squared. Damon, what's 4 squared? What's 4 squared? What's 4 times 4? 16. After 4 squared, I'm going to do 5 squared. David, what's 5 squared going to be? 25. Good. After 5 squared, I go to 6 squared. What's 6 squared going to be, Jaden? What's 6 times 6 going to be? 36. After 6 squared, I'm going to do 7 squared. What's 7 squared going to be? 49. What's 8 squared going to be? 64. 9 squared? 81. 10 squared? 11 squared? And 12 squared. 144. So these are your first 12 perfect squares. Meaning, if I type into my calculator and I want to find the square root of 144, it's going to equal 12, because 12 times itself is 144. What's the square root of 36? So what number times itself will equal 36? So what's the square root of 36? What number times itself will equal 36? 6. What's the square root of 9? So what number times itself will equal 9? I think I heard it. 3. What's the square root of 4? So what number times itself will equal 4? No. What number times itself will equal 4? So what's the square root of 4? Nope. The square root of 16 is 4. But if I have the square root of 4, you have to think, what times itself will equal 4? What number can you take times itself to equal that number?
2.
2. So if I take 2 times 2, basically the square cancels with the square root, and the square root is 2. That's what we're going to talk about. Okay? You all have the first 12 square roots down? Let's go down to example number 1 then. Well, there's your multiplication chart that I said would be so incredibly helpful. Okay, square root of 64. So it's really easy to type into our calculator the square root of 64. And you're going to end up with what when you do that? The square root of 64, if you type that into your calculator, what do you end up with? 8. Okay. Because you ended up with just one number, that's considered a perfect square. Remember how when we did the square root of 50, we got a decimal, and I had to do all that extra work that we're going to learn? That's not a perfect square. A perfect square is when it works out perfectly. How I'm going to have you guys show me your answer is you're going to put the square root of 8 squared. Whoop. And you're going to show me that square and square root cancel out, and then you're going to put your final answer as 8. Now, he's like, why am I doing all this extra work? I understand. I am asking you to do extra work here. I know it's really easy to just put 8 down and be done, but it's going to be a building block and a foundation for what we're going to be talking about throughout this triad. So the sooner that you guys understand that square and square root cancel one another out, the better off we're all going to be in the long run. So what this means, though, you don't have to write what I'm writing in the red. What that basically means, that the square root of 8 times 8 equals 8. Okay? So that second 8 cancels with the square root sign, so you're left with just a single 8. Or the square root of 64 means 8 times 8, or 8 squared equals 64. I know that's confusing. I get it. The more we practice it, the better we become, though. So don't worry about the red stuff. Just worry about the blue stuff. Okay, do we all have the blue stuff down? You guys have got to communicate with me. I can't read your minds. I don't know if you have it down or not. Do we all have it down? Okay, so I'm assuming we don't since we're not talking, so I'll just wait longer until we have all this stuff in the blue down, which means we might have to finish notes tomorrow if we can't get through this. So do we all have the blue stuff down?
Yes.
Thank you. You guys have got to learn to communicate. How many of you guys absolutely positively love math? Okay. How many of you guys wish that you did not have to do math at all because you just don't like it? How many of you guys would still rather be at home and be in bed? Okay. I get it. I get it. Sometimes you'd rather be anywhere than here. But the way you look at it, we're here, we're all in this together. We might as well work together and get through it. All right? The longer you guys sit there with bumps on the log, the less entertaining this class will be. If you guys choose to participate, not only will it make class go better, but you're going to actually learn and retain the information. I hated participating in school, but it helped me remember the information. All right, let's look at example number 2. Go ahead and get that down on your paper. We have the square root of 4. So if you type into your calculator, the square root of 4 equals what? 2. Now, remember, I'm going to make you write it in all this crazy way. Basically, the square root of 4 is 2, meaning 2 times itself equals 4. So what I want you guys to show me is the square root of 2 equals the square root of 2 squared, which squared and square root cancel out to equal the 2. Again, I know it's an extra step right now, but it will not be an extra step next week. You form good habits now, it will stick with you for the newer lessons. So make sure you show all your work how I am right now. I promise you it'll make next week easier. Not only that, but when I go to grade your quiz on Friday, I'm going to want to see this step and this step for full credit. Okay? All right, example number 3. The square root of 144. What times itself, because the square root of 144 will be a perfect square, what times itself will equal 144? 12. So how do I write that, though? The square root of 12, what? Squared. Then I show that squared and square root cancel because they're inverse operations. They're opposite of one another. So that square is going to cancel that square root, and we're going to be with just the 12. Okay? Let's look at example number 4. Two more to go after this one, right? The square root of 1, Jaden, what's the square root of 1 going to be? What's the square root of 1 going to be?
1.
1. Okay, and remember, I'm extra picky, so I'm going to want to see the square root sign, 1, 1 squared. I want to see that squared and square root cancel to equal just the plain 1. All right, example number 5. Did that work for you?
How do you put the square root?
This? This, because that's the, you push the second button to go with that, and then 1. There you go. Okay, example number 5. Example number 5. I have the square root of 5 squared. How do I determine what my answer is going to be here? The square root of 5 squared. Kelly? Yeah. All you have to do for this one, you just cancel that squared sign and the square root sign, because they're inverse operations, they cancel each other out. And what are we left with? We're just left with the 5. So there, you don't have to show me that extra step. It's already written in. So you have the square root of 5 squared. Well, squared and square root, inverse operations, they're the opposite of each other. They cancel each other out. Once you cancel that square and square root sign out, you're left with just the 5.
But if that was 25,
If that was the, so let's say, if that was the square root of 25, what's the square root of 25? So it would be 5 squared, right? 5 times 5 is 5 squared, which would cancel that out, which would equal 5. You don't have, sorry, you don't have to write that. I usually try to write in a different color, so you know. And my last example problem. Are you guys all secretly saying hallelujah? Ooh. Nobody say the answer. Write it down. I'm going to come around and look to see if you can get it.
I already wrote my example.
If you can get it. Let's see. You guys are really dead, so I'll sugar you up. All right. If you think you have it, let me know. I need to replenish my stash of candy too. So write it down. If you think you have it solved, let me know. Grab 2.
We have to write the full problem, figure it out the whole problem.
Yep.
So I have to do 5 times that.
What is that canceling out with?
5.
No, what's that square cancel out with?
That.
What's square cancel out with? What's the opposite of square?
You lost me. Yeah, do that.
Show that it goes all the way through that square root sign. So if that cancels that out, should you still have this sign? Nah, because it got rid of that sign. Get rid of that sign. Almost. I'm going to explain it in just a second. Grab 2. Did he get it? Michael, sit down, please. Nope. Hey, go grab 2. Oh, you're so close. Grab 1. I'll let you grab 1. Where are you at? You didn't even get past go. All right, anybody else want to try before I go through?
No.
Okay, so I'm actually really pretty impressed. Most of you guys were getting it, and that's okay. I don't expect you to be perfect. That's why I don't take accuracy grades on your homework assignments, because you're not going to be perfect yet. So the square root of 5 squared times 7 squared. What happens with squared and square root? What do they do with one another? They cancel each other out. So if this square cancels with that square root sign, this square cancels with this square root sign, how do I rewrite it? Do I have a square root sign left anymore? No, but what do I have left still? 5 times 7. Now, you would never leave a math problem half finished. What's 5 times 7? And there's your final answer. You will have some like this on your